For 2.4, some thoughts. They start out with these absolute value inequalities. One thing that's big about this is remembering like what this means. What does absolute value mean? There's different perspectives on it, but for our purposes, something that's good is we could say that absolute value of any number is just how far that number is from zero. So if I were to say absolute value of something is greater than 5, what that means is that here's 0, here's 1, 2, 3, 4, 5. I'm talking numbers. Any number that I want to talk about, I don't know what number this is, but he's more than 5 steps away from 0, essentially what that means. It's if I say the absolute value is greater than 5, that means it's either 6, 7, or 8, or it's 1, 2, 3, 4, 5. Here's the other 5 that also gives you an absolute value of 5, and -6, -7, -8. Either direction, these things both have absolute values that are greater than 5. So things like 6, 7, and 8, they all absolute value greater than 5. But if I were to put a -6 or a -7 or something in here, then those absolute value ought to be bigger than 5 as well. So we're essentially just saying more than 5 steps away from 0 is all that means. And so we'll keep that in mind, because what that looks like on the number line here as we go through these different inequalities we're looking at is the guy that I'm describing here, the face guy, he's either bigger than 5 that way, or he might be like, that same guy might be less than -5. Like, that's the other situation. He's bigger than 5 or he's less than -5, you know? And so let's keep that in mind, and we'll consider that over here. The absolute value of some mess is bigger than 1. And so if we're starting out with an absolute value being greater than something, it's the same situation as the face guy. Meaning like, we'll solve this thing out for x with the whole plus and minus 4 thing. But essentially right now, we're saying this is the kind of inequality such that I'm greater than 1 step away from 0 all the time. And so what we know from the get-go is that the x plus 4 there is either bigger than 1 or the x plus 4 is less than -1. So it's either one of those things. It's not going to be both because, you can see you're not going to be bigger than 5 and less than -5 before. Same thing here. It's not both. It's one or the other kind of thing. And so it's to be like we'll have to do this answer in pieces probably. And so if I solve these both out, 1 take away 4, if I minus the 4 there, then 1 minus 4 is -3, so I have x greater than -3. Or if I minus this one, -1 minus 4 is -5, so x less than -5. So I want to picture that real quick. Here's 0, here's -3, here's -5, further out to the negatives. I'll circle them both. We don't have equal signs on them, just less thans and stuff. So I'm greater than -3, so that way from -3. I'm less than -5, so I'm that way from -5. So I got to describe that, and so remember how that looks. Is this is going from -infinity all the way to 5, and then from 3 all the way to infinity. And so that's the way we'll union this out. Here we go. -infinity all the way to -5, unioned with -3 all the way to infinity is the way I see that one. Other ones now in your homework, like number 2, number 3, I'm seeing a bunch of these here, have this other situation where we'll say the absolute value of something is less than 6 steps from 0. And so the way that looks is, guys, before we solve this out, if we're talking less than 6 is the absolute value, or less or equal to, or whatever, it doesn't matter. We'll just say less for now, but less than 6 means that we're less than 6 steps from 0. So before we solve this thing, kind of the picture of what we'll be looking at is, here's 6. Things that are less than 6 have an absolute value less than 6 as well. But that also means here's -6, and so things like -5, -4, -3, they also have numbers that are less than, whose absolute value are less than 6. So this is things like 5, 4, 3, or -5, -4, -3. It's things between the 6's in this case. And so the answers that we'll be looking at is more like it's all grouped together, and so we won't probably have to union together 2 pieces of an interval. Probably our answer will just look like from here to there kind of thing. And so let's look at that. So we'll do the same thing here with the x plus 7. Now we'll say that means either x plus 7 now is less than this 6, less than positive 6. Or on the other side, we could say x plus 7 is, if it's to the right of negative 6, it must be greater than negative 6. And that's why it's good to kind of draw these things ahead of time. So we got the idea. We'll say we're either inside of the 6's here, it's going to be either less than 6 or greater than the negative 6. So we're less than 6 or greater than the negative 6. Don't forget the little equal to signs on this one. And then we'll solve them both. On this case, we have x, and we'll minus the 7. 6 take away 7 is negative 1. So we're less than negative 1 or equal. And then minus the 7 over here, we have x greater than or equal to negative 13. And so let's picture that now. We're talking, here's 0 or whatever, that's whatever, and here's negative 1. We're less than or equal to negative 1, so that way. And then negative 13 happens way over here. We are greater than negative 13, so that's to the right. So we are sandwiched between the two. And then we'll say the equal to signs will color us in on the circles there, it's whatever. But we got to figure out a way to describe that, and it looks like for us the best way in interval notation is just to say that the solution set is anywhere from negative 13 to negative 1 inclusive. There's a 1 there, whatever. And that's what we'll say. It's from negative 13. There's a 1 there. Negative 13 to negative 1. Looking good. And then some other similar things. Comment on something like number 4. You might notice that it just has stuff dancing around outside of the absolute value. It's okay to just get rid of that. It's at times of this negative 3, so don't plus it or anything. It's timesing, so we'll divide it. And that'll be kind of gone from there. And so now we'll say absolute value of x minus 2 would be, and then what's this going to be? 3 into 6 is positive 2 now. But just watch out, like we had said before. Remember, if you divide by a negative, which we're doing, then these absolute value, or sorry, these inequalities, they switch around. So then you'll start from there, and it'll be kind of like number 1. Okay. What else? Another kind of problem that you'll encounter. So like number 9 here. We have to solve the quadratic inequality. This one's a little bit more intense. There's no absolute values on it, but it's quadratic, and so it's a little bit weird. It's hard to know what numbers. We're essentially trying to figure out what numbers can I plug in for x that will make this thing all equal or be less than 0. And so we're used to equaling things to 0, and that'll be illuminating. But to know when we are less than 0 is going to be tougher, because you could just try stuff and, I don't know, eventually kind of figure it out. But it seems like one thing that would help to illuminate the situation is let's go ahead and figure out where it is that we hit exactly 0. And then we'll try some other numbers around whatever that is to figure out when we are less than 0. Okay, let's see. If we did this by factoring, let's see. X and x. And we'll just, first off, let's figure out where we hit equal to 0 at, right? And then factoring, what goes into 12? I'm thinking like negative 3, negative 4. That should work. And so then, if we're wondering what numbers can I plug in for x that makes this thing actually equal exactly 0, looks like positive 3 minus 3 makes a 0 here, so we have x equals 3. And then positive 4, take away 4 would make a 0 there. So looks like 3 and 4 are the numbers that would make it to be equal to 0. And then we got to figure out, well, what happens if you try 3.5? Is that going to be something like it's not equal to 0 there, but is it greater than or is it less than 0? I don't know. And so, I don't know, maybe let's just picture that real quick. There's all these numbers. If I'm looking at a number line of all the domain of just the numbers that I could plug into this function in the first place, what we found out is that if I plug in the number 3, I hit 0. If I plug in the number 4, I hit 0. So neither one of these is going to work for the less than 0 thing, because it's actually equal to 0 there. So I'm going to leave these open because we don't have an equal to thing involved in our little less than here. So we don't get to close the circles. But what we know is that these are not part of the solution because they make it equal to 0. They're not less than 0. What I don't know is the rest of the number line. I don't know about anything over here or anything over there or anything between 3 and 4 if they're less than or equal to 0. Or sorry, if they're less than or greater than 0. So what we do is we typically just try stuff. I'm going to try a number that's somewhere between 3 and 4. I'll try something in there and see if it gives me less than 0 or greater than 0. Then I'll try something over here, something on the other side of 3. I'll try something there, and I'll try something over here on the other side of 4, a number that's like 5 or something that is just bigger than 0, so that one will represent what numbers that are on the other side of 4 will do. And so we'll just try stuff. So let's see, well, let's try, on the other side of 3 would be 2, or 1, or 0 you could even do if you wanted to. With all the zeros involved in this, I don't want to confuse people. So I'm just going to try 2, because that's right next to the 3 over here. Over here on the other side of 4 is like a 5. We could try 5. And then between 3 and 4 is a little weird, so we could try 3.5 or something. Try 3.5. And then we'll just see which parts of this actually end up giving us something that's less than 0 versus same thing that's greater than 0, because we know that 3 and 4 give us exactly 0. And so we'll just try that. Let's see if we try it 2, then 2 squared minus 7 times 2 plus 12. Let's see if that does what we want. 2 squared is 4 minus 14. 4 minus 14 is negative 10, I guess. Plus 12. That's positive. This is positive 2. That's greater than 0. That's not what we wanted. We're hoping for less than 0. So that's out. Things to the left of 3 are not in it. Not what we're describing. Let's try, 3.5. I don't want to try that. Let's try 5 first. And then 5, if we plug in a 5 there, let's see here, that's 5 squared minus 7 times 5 plus 12. 5 squared is 25 minus 35. 25 minus 35 is negative 10 plus 12. Oh, great. This one neither, and this one's positive 2 as well. That's greater than 0. That's not what we want. So that's out. So we're like, probably 3.5 will do us what we want, and I'm betting that the solution set is everything between 3 and 4 then. So it must be this part that's between 3 and 4 that actually works. But let's make sure real quick. And so regular 3.5, if we do 3.5 squared, and then minus 7 times 3.5, and then plus 12. Let's see how that goes. 7 times 3.5 would be half as much as 7 times 7, so half of 49 would be 24.5. 0.5 minus, and then that means this is half as much as that, so this is 12.25 minus 24.5 plus 12. Let's see, 12.25 minus 24.5. This is twice as big as that, said to be a negative 12.25 plus 12, and that is less than 0, because this is bigger than the positive. So negative 12.25 plus 12 is less than 0. That's negative. This looks like the golden goose. So things that are between 3 and 4 looks like that's where we get to shade our solution in, this part of the number line. So I guess that's what we'll say, is the solution is just between 3 and 4, no equal to's on this, so I don't get to color in the 3 and the 4. So we'll just say from positive 3 to positive 4, that's my solution set. Looking good.